not do all of this, we're going to graph this equation. And we're going to graph this one in blue. And that's nothing new. That's exactly what we did in section 3.3. And then we're going to graph that one in green, and that's what we're doing in this section. So 3.4 combines what we learned in 3.1 to 3.3 all together. And what we do today in 3.4, that's not on your quiz tomorrow. Your quiz just goes up to 3.3, but this will review some of the stuff you need to know as well. Okay, so first of all, the red graph. I'm going to draw some axes on here. There's your absolute value of x graph. And then when we go to the blue equation here, can you see that this 1/4 is out in front of the absolute value? So that's going to be a vertical compression. You're going to multiply your y values by 1/4. And the 2 here is inside the function. That's going to be a horizontal compression. You're going to multiply your x values by 1/2. And so what we did in the last class to show this is we said, well, we're going to take some key points on our original graph. Like 0, 0 is a very important point. And then I'm going to take a point on the right-hand side and one on the left-hand side to show those transformations. Now, it doesn't matter which points you choose, but some points will end up being nicer than others. For example, if you look, what do we want to do? We want to multiply our y coordinates by 1/4 and our x coordinates by 1/2. Can you see that if I choose 4, 4, that's going to work out as nicer numbers because they divide by 4, and we need to multiply our y coordinate by 1/4? You could choose 3, 3, but you'll just have to work with fractions. Same thing on this side. I'm going to choose -4, 4. So then what we do is we set up our points. We've got 0, 0, 4, 4, and -4, 4. And then I'm going to have this blue arrow here showing on my blue graph what changes. Well, I know that I need to multiply my y coordinate by 1/4 and my x coordinate by 1/2. And so when multiplying those, these will still be 0, 0. Y coordinates will change to 1. X coordinates, this one's going to be 2, and this one's going to be -2. And I can label those points on my graph. So I have 2, 1, -2, 1, and there's the blue graph. So that blue graph matches up with that, and that's exactly what we did in section 3.3. Okay? Yes?
In this case, do you draw the arrows like all the way to the end?
Oh, like do I have to have this go right to the end of my graph before I put the arrows? No, you could have had your arrowhead short here. It doesn't, you could, if you really like drawing lines as much as you could have the arrowhead over there.
So one arrow should be that long together.
Yeah, that would be fine.
As long as you have the arrow.
As long as you have the arrowheads on the end. Your textbook always ends their graphs at the edge of the graph because it just sort of has like cut it out and ended it there. But where you have those arrowheads doesn't matter. That looks a little bit awkward though. Okay, so that was what we did in 3.3. The green is what we're going to be adding today. Well, can you see that the green is just the blue one, but now we've gone 3 to the left, right? This is going to be a horizontal translation 3 to the left, and this is a vertical translation 4 up. So what we're going to learn is that when we have a whole bunch of things together, we're going to do our stretches / compressions first, and then we can show this 3 to the left and 4 up, our translations, second. And so if I take these points, 0, 0, 3 to the left, and 4 up, -3, 4. 2 to the 1, 3 to the left, 4 up. This one, 3 to the left, 4 up. And I take this graph, and that green graph matches up with that green equation. Yes? You will always do the translation second. In fact, if we labeled on the green equation, you could have labeled this as horizontal compression x by a half, right? And this as a vertical compression y by a quarter. And we're going to go from left to right, just like you'd read a book. If you went from left to right, all of your stretches and compressions you can do first. And you'll do those at the same time. In fact, even if there was a reflection in there with the negative, you would do stretches, compressions, and reflections first. Then your second set of arrows is always your translations afterwards. And you just go from left to right. And so it's relatively easy and straightforward. So we're going to turn and do example 1. So they give us the graph of g of x. It says sketch and label its image after a vertical compression by a factor of 1/3, then a translation of 2 units up. So in what they're asking us to do is everything is vertical. If I wanted to write the equation of my new graph, everything would be outside of the function. A vertical compression of 1/3 would be outside in front of g of x. And a translation 2 units up would be outside of the function and plus 2. So we can take our original points. So we have -5, 3. We have -2, -3, 1, 0, and 4, 6. And since we have stretches and translations, both of those things will happen. We always do our stretches first. So this, and I'll label it this time, but after this, you'll probably not label stretches with an E, right? And underneath, what are we going to do? Well, this 1/3 is a vertical compression. You're going to multiply your y values by 1/3. So above here, I'm going to write y by 1/3. And the plus 2 is a vertical translation. You're going to go up 2. So here, I'm going to label that as 2 up. After the whole thing. Otherwise, sometimes your graph gets really busy and hard to follow. So y by 1/3, we're going to get -5, 1, -2, -1, 1, 0, and 4, 2. First of all, the important thing to notice here is, can you see the mental math is not hard, right? Next, we're going to add 2. mental math-wise, that's not very hard, okay? In fact, sometimes it's so easy that you're going to be tempted to not pay attention because you're like, I can add 2, and you'll start thinking about what you need to do next. And it's when you start thinking about what you need to do next, that's when you're going to make all your mental math errors. I told my other class, I don't know if you ever do this, you're like doing a task that's super easy, and you're thinking about what you need to do next, and then you do the task completely wrong, okay? Like sometimes I wear contacts. If I'm thinking too much in the morning about what I need to do, I've put the same contact into the same eye. It's just like, you're like, this is easy. It's easy for me to do now. I do the same thing twice, okay? Growing up, I told a story to my other class. My mom, you know, she'd be putting away stuff after breakfast or after supper. And then she'd be thinking about what she needed to do in the rest of the day. And later in the day, there was a reward. If anybody could find the butter, because she was thinking about something else and put it away in the totally wrong spot. We'd find butter in the basement. We'd find butter in the freezer. We'd find butter in the cupboard with the cereal. It was because she was already thinking about the next thing. Putting away butter is like, goes in its spot. It's super easy. It's not hard. But if you start thinking about the next thing you need to do, your brain can just like not pay attention, right? Probably the worst thing, TV remote. I just put it down. I don't know where I put it down, and it bothers you. So what you need to do is when multiplying y by 1/3 and then adding 2 up, even though that's easy, if you're not paying attention, your brain will all of a sudden, oh, I'll switch to the x coordinate. Just because I'm not paying attention. So one of the things I want you to do is like, after you do it, do a check. Did I do it right? Yes, did I do it right? You can check after you've done all the points, or sometimes 2 up, -5, 3. Did I do it up with the y? Yes. -2, 1. Yeah, that's good. 1, 2, check. 4, 2 becomes 4, 4. And if your check is the next thing you're going to do, then you're not going to make a mistake on what you're going to do because you're checking as you go along. So there's little things that help you avoid those, like, who hasn't got a math test back where you go and you look at your results and you're like, I'm an idiot. 2 + 3 and I wrote 6. Because adding's easy, but my brain said, let's multiply. Why not? Because you're not paying attention just for that brief second. Okay? Now we can take those points, -5, 3, -2, 1, 1, 2, and 4, 4. Ooh, careful. And label them. Connect the dots. And then the last thing that you can do as a check, almost connected the dots. The last thing you can do as a check is look at your words. Vertical compression squishes towards the x-axis. Vertical translation, in this case, moved it up. Does this blue graph look like it's been squished and then translated up? If that looks right, then you're feeling pretty good. If you're, like, sometimes I've had students, connect the dots wrong, right? Does that look like the graph that I started with? No. So then it's sort of telling you, hey, maybe I did something wrong. Now, there's something important that I want to show you on the example in the textbook as well. So we're going to go back to this one. We're not going to do it completely, but with horizontal compressions and translations, if I wrote this out, there's 2 different ways that you could think about writing it. One of them is right, one of them is wrong. And this only happens with horizontal stretches and translations. So here we have a horizontal compression by a factor of 1/2, then 3 units to the left. So here are 2 ways. First of all, both of them are inside the function, right? So we're going to have stuff inside the function. A compression by a factor of 1/2 would mean you would have a 2 inside the function. And then a translation of 3 to the left, you would have a plus 3. So the question is, should I write it as 2x plus 3 like this, or should I write it as 2 and put the x plus 3 in a separate set of brackets? Does it matter? Yes, because if you distributed this one, you would get 2x plus 6. So they're different. One of them is right. One of them is wrong. Okay? Now, if we go back to what we did, our first example, and check the first example, we went 3 to the left. How was it written? Was it written with the x plus 3 in brackets or not? It was written with the x plus 3 in brackets already. So in this one here, this is the one that is correct, and this form is wrong. Okay? But this form looked nicer, didn't it? Wouldn't you be tempted to want to use that one? Okay? Yes. So what we're going to do is at the bottom of the page here, we're going to add a special note. So when you have a horizontal either reflection or a stretch or compression, in other words, any number in front of the x, even if it's just a negative, and a horizontal translation. You must write the equation in factored form. And this is going to catch some of you often. So many times that one year I had a student who put a reminder into their phone for 10 p.m. every night. And the reminder came up. Remember, when you have a horizontal reflection, stretch, compression, and a horizontal translation, you have to write it in factored form. Because you have to say, well, sometimes they say you need to like hear something or do something 7 times before you really know it. And if you just see it once in your notes, it's not going to, you know, it's not until we go over this 7 times will you start not making that mistake. So they decided to put a reminder in their phone all semester long. Now, if you did that with every important thing that you're going to learn in this class, you're going to get reminders from like 7 p.m. until midnight. Just be over, oh my goodness, there's so much stuff I have to remember. But this is one of them that you're going to find you're often going to make a mistake. So for example, right, if I asked you to graph y equals the square root of negative x plus 7, I should write that negative even nicer. That looks not. Negative x plus 7. Can you see yourself seeing the plus 7 and wanting to go 7 to the left? But this one, because there's a horizontal reflection, you would have to first factor out that negative. So horizontal reflection and 7 to the right is what would happen. So that note that you always have to write it in factored form will come up over and over again. Anyways, questions for the first one are 4, 5, and 6.